Hi kids, it's Mike. I want to talk to you today about seeing patterns in your data. Now, it's kind of hard to look at a table of numbers, just a big pile of numbers, and detect any patterns in your data. It's more helpful to look at some graphical representations or some graphs of your data. So I'm going to do that in just a minute, but we're going to talk about a couple of different things in your data, patterning in your data. One of them we're going to talk about is clustering. We're going to talk about looking for peaks and for gaps. I'm also going to talk about this thing called symmetry. So if you don't know what symmetry is when you can look at something, maybe you're looking at something like this, and you flip it around like that, and it looks the same. If it looks the same this way as it does this way, that's symmetric. So my hand does not have good symmetry because I've got a thumb on this side, and when I flip it this way, I've got the thumbs on the opposite side. If I just look at those four fingers, they're actually not too bad as far as symmetry goes, because those four fingers that are kind of low on the sides and high in the middle there, they have good symmetry with these four fingers if you ignore my thumb, because it's still low on the sides and high on the middle. Okay, so we're going to talk a little bit about clustering for a second, but you actually already know what clustering is, but maybe you just never thought about it in this way. For example, do you ever go to the grocery store with your mom? Big parking lot, and half of it's completely empty, and half of it's got cars in every single stall, and those cars are clustered together. They're not randomly spread throughout the parking lot, they're clustered together. Well, why are they clustered together? Because people don't want to walk very far from their car to the grocery store, so they kind of tend to cluster at the front door. Have you ever been to a strip mall where maybe there's a pizza place here and a couple of empty stores here because they went out of business, and then there's a dog grooming place over here? Well, if you look at the cars in front of that strip mall, they will cluster towards the businesses that are open, and there'll be a lot of empty spaces where the businesses aren't open. Or here's another example. How many of you ride your bike to school? So when you get to school, you just toss your bike down anywhere you want in the playground? Well, no, you don't. Probably for two reasons. Number one, it's probably against the rules. You can't just go leave it by the door of your classroom, or you can't just leave it out in the middle of the field. But they tend to cluster, the bikes will cluster at the bike racks, because you probably want to lock your bike up also. You don't want anybody to steal it. But that is a form of clustering. Now there's a reason for that clustering, but it's a form of clustering anyway. So I want to show you a couple of pictures of what clustering looks like when you look at a graph. Now, once again, like I say, it's looking at a big table of numbers and trying to figure out the clustering that way is really kind of difficult. It's so much easier if you do a graph. So what I've got here is I've got a histogram. I'll try and hold that real still so you can see it. So I've called this histogram with clustering. So I took a bunch of data. Do you remember how to do the histogram? Kind of create these little bins that have a certain width in the bottom, and you count up how many values fall in that bin, and you make the bar as tall as that many values. Anyway, this is a histogram, but clearly there's two different groups of data going on here. You see this? There's one group right here that's kind of clustered around this area, and there's another group over here that's also clustered in this area. Okay, and we've got a gap here, and we've got this one little lonely guy right here in the middle between this gap. He doesn't know which group he belongs to. And you can see that there are peaks. Now you could get real technical and you say, well, there's a peak here, and there's a peak here, and there's a peak here, the tall peak, but then I've got this other peak here and this other peak here. Well, if you're saying that, you're probably looking too closely at the graph, but you got to kind of squint your eyes a little bit, make them a little fuzzy, and say, yeah, the peak is somewhere in this region here for this cluster, and the peak over here is somewhere in this region here. You remember when I did my, let me see if I can find it. When I did my histogram from, you remember when I was scooping the balls out of that little, I don't even know what it's called, that little contraption the other day, and my histogram ended up looking like this. Now, some might argue that this has two peaks. I would say, no, it probably doesn't. It's probably just one peak. And if I would have done this instead of 30 times, if I would have done it 30,000 times, let's say, you would get a really nice, very pretty distribution there. Here's another example of clustering. This is with a scatter plot. Now, we haven't really talked about scatter plots here, but let me show you what this is. So scatter plot is when you actually have two pieces of information from each data point. What I've done here is I've drawn a height and weight scatter plot. So on this vertical axis here, I've got height, and that's in inches, starts at 44, goes up to 54. And then along the bottom, I've got weight, starts at 50 pounds and goes up to 110 pounds. Is that what that says? And then, so I would grab a bunch of people and I would weigh them and I would measure their height. And if their height was 48 inches, I would go up here. And if their weight was 56 pounds, I would go right there and I'd put a dot, a single dot for that person. And I did that a whole bunch of times for a bunch of different people. And can you see if after a little while you get a bunch of data together, it kind of makes a little bit of a cloud. Okay, the cloud of data. There's another one over here. Well, this is a good example of clustering also. Now, if you grow up and you want to be a statistician professionally, you would look at this and you would say, something's going on, something's different between those two groups. I wonder what it is. And then you would go and investigate it and try to figure out why there was one cluster over here and another cluster over here. And maybe you might discover that, oh yeah, well, everybody in this pile right here, everybody in this cluster, this little grouping here, is a third grader, whereas everybody in this cluster over here is a seventh grader. So you can see how the clusters really define differences between two groups. Okay, so that's a little bit about clustering and gaps and peaks and just kind of looking at your data and making some judgments visually about them. I want to talk about one more thing. This is called symmetry. And I told you a minute ago, if I ignore my thumb, this and this are symmetric. But if I don't ignore my thumb, this and this are not symmetric. Because this one goes like this. And over here, my hand goes like that. It falls off that way. So I'm drawing you some pictures here that shows good symmetry at the top. Can you see in your mind's eye, can you flop it like this, okay, turn it like that, just in your mind's eye, make it look like that in your mind. Does it look the same? If it does, that's good symmetry. We call that symmetric. These other two graphs below, maybe I'm teaching you a word you don't need to know yet, but these are skewed graphs. Can you see this one's called right skewed? Because the data, the distribution is kind of squished out over on the right side. It's like somebody took a pile of data and put maybe a big pile of dough or something and put a heavy rolling pin on this side and kind of squished it out that way, made it right skewed. The bottom one is left skewed. And there's lots and lots of data that naturally appear as either being right skewed or left skewed. Also lots of data that naturally appears as being symmetric. But I just want you to be familiar with those shapes a little bit to see what they look like. Okay, so that's it. That's all about clustering and peaks, gaps, symmetry, just some different shapes you want to look for in your data as you're collecting data. Okay, have a great day. We'll see you tomorrow.